In this video, I'm going to show you how you can use an EEPROM BIOS programmer to dump the firmware from this router. We'll also be using a couple Linux command line utilities, binwalk, as well as flashrom. Let's go ahead and get started with the video.
This is a Fresh Forensics production.
This is just a old cheap router that I picked up used for about $5. This is just a great device to learn on, as it has different interfaces on it that we can connect to. So right here you have 4 pads, and those are the debugging ports associated with the UART protocol, and we took a look at those in a previous video. What we are doing today is we are dumping the firmware sitting on this chip right next to the UART pads. This is your typical SPI flash memory chip, and on an IoT device such as this one, this is where pretty much everything is stored, not just your bootloader, but the entire operating system. As you can see, the chip has 8 legs on it, 4 coming off of each side of the chip to the board. In order for us to get access to the firmware on this chip, we're going to be making use of a special tool, an inexpensive tool, but nonetheless a special tool. This is basically a microcontroller that is built for the purpose of reading and writing to these flash memory chips. This is not the only device that you can do this with, but this is probably one of the most popular ones on the market. So what you have here is this microcontroller that attaches to your system via USB, and we have this lever right here. I can actually pop this up and I can pull this out, and there are different adapters that we can use to plug into this. So I just pop that in like that, go ahead and close that arm, and it locks it in place. You can see here that it actually says SPI BIOS EEPROM on the back side. And then what you have is this ribbon cable that runs all the way to this chip clip. And if you look at the chip clip here on the very end, there are metal tips inside of those jaws, and there's 4 on each side. So you are able to take this chip clip, it fits right over top of that flash memory chip, and you secure it over top of it. It makes contact with those legs, and we are able to read and write data to and from the chip. Something that's always good to have handy. I'll be using it for this example. This is an OTG adapter, and this is because the laptop that I'm going to be doing this from, the USB ports are so close to one another that it would be very awkward trying to get the programmer into one of those ports. So I'm just going to use this. Another option would be to use a USB extender, but mine is currently in use for the recording of this video, so I'm going to have to use this. So I'll go ahead and plug that in. Now I'm going to put the router back underneath the camera here, and I'm going to try to get a close-up of this SPI flash chip. And what I want you to see is that in the upper right part of this chip, right there in that general area, there is actually a little dimple in the chip. You see that? and there's also an arrow or a triangle pointing to that leg. Those two identifiers are meant to let you know that, amongst other things, when you are using the chip clip, that is where you're going to want the red wire in this ribbon cable to connect to. So now what I'm going to do is I'm going to attach that chip clip to the SPI flash memory chip. As much as I would like to get this on a close-up underneath my desktop camera, I just don't think that that's going to be possible. So I'll show you what it looks like after it is connected. By far, this is going to be the hardest step in this process because sometimes there can be things blocking you from getting the chip clip over top of the flash chip. And you also have to pay close attention that you are making contact with all of the legs. But I do have it attached, and I will try to get a close-up of that. So there you go. You can see that the chip clip is over top of the chip. And now I'm going to move over to my Kali Linux machine and get ready to plug the programmer into the machine. First thing that I'm going to do is create a directory to store anything that I do in this video, such as the firmware that I am about to dump. I will call that directory Belkin because, spoiler, that is the manufacturer of this particular router. I'm not really focused on that. The whole point is to just show you how you can use this methodology to dump the firmware from any IoT device. Once I've created the directory, I will cd inside of it. And now I'm going to run the dmesg command with sudo privileges, and I'm going to do a -w. And what that basically does is it will continue to print new output to the screen as kernel messages come in. And we're going to receive kernel messages here in a second when I plug this programmer into my machine. Okay, I just plugged it in. You can see that we had some information printed to the screen and everything looks good. One of the things that I'm looking for is to see if we have any errors, and we don't have any errors. And also another thing I'm looking at is to make sure that the lights are powering up on the programmer as well as the router. So you can actually see that there is a power light that is blinking on the router. And that is important to note and also very interesting to note because we do not have the router plugged into a power source. So that lets you know that it is actually getting power from this ribbon cable that is attached to my machine. So these are all good indications that we are on the right path. I can also give you a view of the programmer, and you can see how that looks when it's plugged in. You can see that the power indicator light is on the programmer. I will Control-C from this, and another thing that we can do is we can run ls USB, and we can pipe the output into grep, and I'll do -I for case insensitivity, and we'll grep for a string that we know is going to be associated with this device, such as CH341. And here's an entry that we get back for that, letting us know that our system is registering it. All good things. But now here is the most important part. So we're going to be using a utility called flashrom. If I do apt info on flashrom, we will get back that this tool can be used to flash BIOS firmware images. And it gives a list of currently supported programmers. And the programmer that we are using in this video is this one at the very end. If you do not have flashrom installed, it's very easy to install. You simply type the command sudo apt install flashrom. To pull up the help menu, we can run the command flashrom --help. One of the main options we're going to be using is the -p option to specify the programmer that we are using, and the one that we are using is this one right here, ch341a_SPI. So the first thing that I'm going to do is run the command sudo flashrom -p for programmer, and I'm going to give it the name of my programmer, which is ch341a_SPI, and I will hit enter. Now I'm getting back something telling me that it cannot write if the chip is not found automatically. So that to me is saying that perhaps one of my contacts on the chip clip is a little loose. So this is something that happens often. These things can be very finicky. So I'm going to double check my connection. Okay, I just took another look at the connection and did a little adjusting to it. Let's go ahead and rerun this command and see if we get some results. And that time we did. So this just goes to show you that even though everything can appear to be connected properly, one little thing that's just a little bit off can make all of the difference. So by running this command, the main thing that we have done is we have allowed it to get information on the actual flash chip that is on this device. And it says right here on this line that it found an Eon flash chip, and this is the name of the chip. And this is very important, so we're going to copy that and now I'm going to rerun that command, and we're going to add a -c and specify the chip. And finally, I'm going to do a -r for read. It will read the contents of the flash memory chip, and we are going to dump the contents, and therefore we have to provide the file with a name. So we will call this router.bin and hit enter. There we go. So it has finished. I will clear the screen and run ls, and we now have a file called router.bin. At this point, I do not need to have any of this connected any longer, so I'll go ahead and disconnect the programmer and get that out of the way. All right, so now let's go ahead and do a couple quick things. Let's get a general size of this file. I'll run ls-lh on router.bin, and we see that it is 2 megabytes in size, pretty small. I can run the file command on this blob, and we get back that it is data. Now obviously if we were trying to open this up, we wouldn't be able to read anything. If we tried to cat out the contents of this, we're going to get a bunch of gibberish back. But one of the commands that we can immediately run to pull some information from this is going to be the strings command. So if I run the strings command on this, I will do a -n and give it the number of 9, and what that's going to do is only print human readable strings that it can pull from this binary that are at least 9 characters long. And as you can see, immediately we see some very human readable output. That is a great sign that we're not dealing with anything that is, say, encrypted, for example. You can scroll up to the top. And we're getting some very good information. Immediately we can see we have IP address information, the MAC address of the device, as well as some information that appears to be in XML format. Okay, you might want to save all of this to a file, so we could rerun that command and redirect the output to a file that we will call strings.txt. That way we can look at that later and possibly grep that file for particular strings of interest. But the next thing that we're going to do is we're going to use the binwalk utility. So if I do apt info on binwalk, we'll get back that binwalk is a tool for searching a given binary image for embedded files and executable code. It is designed specifically for identifying files and code embedded inside of firmware images. It uses custom magic signature files, which contain signatures for various files that are commonly found in firmware images, such as compressed and archived files, firmware headers, Linux kernels, bootloaders, file systems, etc. It has a very large set of options. If I do binwalk -- help, it'll pull up all of those options. We're going to be keeping this very simple, and we are only going to be using one of these, and that is going to be the -e option, and that is used to extract known file types. If you do not have binwalk installed on a Debian-based system, it's incredibly simple to install. You just run the command sudo apt install binwalk. So I'm going to run the command binwalk. We do not need sudo privileges for this. And I will do a -e and provide it with the name of the binary, which is router.bin. Clear the screen, run the ls command, and now we have a new directory that has been created. We will cd inside of that directory, run the ls command, and look at all of this wonderful data that we now have access to. None of it appears to make much sense, so very clear that they are applying some basic form of obfuscation to the naming conventions of these files. You can run the file command with an asterisk and look at different file types. We have HTML documents, we have XML documents, we have JavaScript source code. You can also run ls-lh and take a look at the sizes of some of these files. I see at the bottom here we have another directory called pfs root. Let's see if there's anything inside of that. And there's another directory, a www directory. So let's go ahead and do ls on pfs root and www, and we have a doc and an images directory. So let's check the doc directory first. Files that pertain to the web server that is running on this device. And we also have the images directory, and here are all of the images that are going to be related to the web server that is running on this device. Another thing that we could do is we could start grepping for key things and see if we can get information related to the user or the password or any APIs, various things that are residing in the entirety of this file system. So I could do a grep with a -r for recursion and a -i for case insensitivity. I will grep for the string pass, and it'll give back to me anything that has this string inside of it. Clearly we get back a lot of information. Over here on the left in purple, you can actually see the name of the file where it is pulling this string from, and there's a lot of information to parse through. And this is a process that we could continue for quite some time, where we grep for key strings such as API, or we could look for the root user if there is any, etc. and so forth. You get the idea, right? So there you have it, ladies and gentlemen. We have used a $10 device to dump the firmware from a router, and then we were able to use the binwalk utility to unpack the firmware image, and we were able to do a basic examination of some of the files that reside on this device. If you made it to this point in the video, thank you so much for watching. If you haven't done so already, please subscribe to the channel, like the video, post a positive comment, and as always,
Stay fresh.
we'll see you in the next one.